you have chips?
It is. I just turned it on. Okay, this is where we were. We talked about an atomic mass unit being 1/12 the mass of a carbon-12. We talked about this bottom left number being what we call the atomic number. And we get the atomic number from the periodic table. It's in the lower left-hand corner. That's where we write it. You could either be given the atomic number or you could be given the symbol, and you'll be able to figure out which one is missing. Okay? And then the last thing I told you was that number could also be called the nuclear charge. Okay? Now let's examine why it would be called nuclear charge. Well, if we go back in our notes, we have this little diagram here that we wrote out. Inside the nucleus, there is only one thing that has a charge, a proton. So it makes sense that the nuclear charge would also be the number of protons. So now let's pretend, I saw it. I found a dead one in the back too. Let's pretend that we're taking a test, and the question is, what is the atomic number of magnesium? You're going to say 12. Is somebody at the door again? No. If it says, how many protons does magnesium say? You're going to say 12. If it says, what is the nuclear charge of magnesium? You're going to say 12. Now, I would personally say positive 12 because the charge on a proton is positive. So it is a positive 12. Okay? So that's three things that number is telling us about. There's one other thing the number is telling us about, and we're going to write it down right now, and that is the number of electrons. Keep in mind that this little E with a minus sign right here means electron. It's another way of writing it so you don't have to write the whole word electron out. I don't know if I told you that yet, but there's the E minus. Number of electrons in a neutral atom. Neutral means that the thing that we're talking about, the particle we are talking about, has no charge. So if you're neutral and you know that your nucleus is positive, let's say it's positive 12, like the magnesium says. I feel like I'm yelling. Are you guys okay? All right, I'm going to stop. Magnesium is a positive 12. Then I know if it's neutral and it has to add to 0, then this number needs to be negative 12. And what's the only thing that we have in the atom that is negatively charged? The electrons. So the number of electrons and the number of protons are going to be the same if the atom is neutral. Okay, let that sink into your brains for a second. Everybody okay with that? Now, they don't always say neutral atom. They might just say atom. How many electrons are in an atom of oxygen? Okay, so let's say how many electrons are in an atom of oxygen. So there's the question, right? So we have to dissect. What's the matter? Are you okay?
Yeah. I just asked the question. So if it says it's just an atom, so it's going to be neutral, and then
that's where I'm going with that, right? I want everybody to understand that if it says this word atom, that's not a good thing to highlight in orange when you're writing in red, but okay. If it says the word atom, you need to know that that means neutral. Okay, so we're going to dissect this question, right? How many electrons, so we're looking for electrons, in an atom, always neutral. Of oxygen. So now we know that oxygen has the symbol O because it's one of the 35 that I asked you to know. Okay, it's a nice easy one. What number goes in the bottom left-hand corner for this oxygen? Where do we find that? In your periodic tables. So do you have them in front of you? No. Let's go grab one. What's up? Oh, periodic table, how we love you so. Yeah, I'm listening. Sure. Okay. Panak, you see that rock that's right there by the door? Okay, stick that right inside the door so that when you get done with the water fountain, we don't have to get up and let you in, please. Thank you. Well, that's what I do. That's my rock. Just click it with your feet. Yeah, just a little bit inside the door. There you go. Yeah, there is a door stopper, but it doesn't work as well as the rock. Okay, so what number is going to go here? 8. You can't see anything. So this is an 8, which means this thing has 8 protons. It also means its atomic number is 8. This is a fat pen that I'm writing with here. It also means that its nuclear charge, that's better, is going to be positive 8. How many electrons does this oxygen have? 8. The electrons is going to be 8 because it is an atom of oxygen. So the number of protons and the number of electrons are going to be equal to each other. So this number right here in the bottom left corner is huge because it tells us so many things. It tells us protons, it tells us atomic number, it tells us the nuclear charge, it tells us the number of electrons. It's all the same number. They could just ask the question 4 different ways. See? There you go. The rock worked. Okay, you ready to move on? Sophia, you good? Okay, Emma, you good back there? Okay, let's look. We know what this number is. Let's look in the top left corner now. So now we're doing this box right here, top left corner. The top left corner stands for atomic mass. If I pull up the periodic table, here it is, you'll see it says atomic mass here, and then there's a number, 12.011 for carbon. Okay, and if you look in the upper left-hand corner, you got a bunch of them up here. See it? They're ugly numbers. These are very ugly numbers. Okay. The atomic mass is an average of all the atoms of that element in the world. Okay, hold on. It's kind of funky definition because you don't know the words yet, so I kind of summed it up. And this is what I want you to think of. Let's say we're talking about oxygen. Okay? In that box, that oxygen box, you guys finish writing that down, then I'm going to flip back to my reference table, my periodic table. Good? Willow, you good? Okay. I'll put it back in a second if you need it. Alright, let's do carbon. Why not? Because it's right here in the middle, it's nice and big. Alright, so this is a house. Okay? And there's carbons here in Port Jeff Station, and there's carbons in New York City, and there's carbons in Hawaii. There's carbons everywhere. Okay? They all live in this house. I know that's kind of hard to imagine, but they all live there. The carbons that are in Hawaii and the carbons that are in New York City and the carbons that are in Port Jeff Station are all carbons because they have an atomic number 6. That's what identifies them as carbons, no matter where they go in the entire world. However, some carbons might weigh 11 some carbons might weigh 12 and some carbons might weigh 13 or 14. Okay? This number right here that says atomic mass is the average of all the carbons in the entire world. So if you're thinking about it as a family, right, you might have a little itty bitty baby living there that might weigh 50 pounds. Well, that's a big baby. Wait a minute. Let's say 15 pounds, right? A baby, like a real baby. And then you might have a toddler that might weigh 50 pounds. And then you might have like a dad who might weigh 205 pounds. The average of all the weights of all of the people that are living in that house is that number. Okay? Do you understand? Now, that number that is an average is called the atomic mass. There is another number, it's in the same spot, but it will be a whole number. That is called the mass number. So this box can also be something called the mass number. The mass number is the exact mass of that exact atom. The daddy weighs 205 pounds. That is his mass number. The baby weighed 15 pounds. That is its mass number. Okay? The average is all of them together, and that is what's given on the periodic table, the average. The mass is the mass of each individual atom. Capiche? Okay. Now, let's pretend that we are back at the carbon family, and in the carbon family, you have one daddy, 205 pounds, one mommy, 150 pounds, and 4 babies at 15 pounds each. What's the average weight of that house going to be? Is it going to be closer to the 205 pounds where the daddy is? You know, I got to draw it so you remember. Okay, so here's the dad. Look how nice he looks. He weighs 205 pounds. Here's the mom. Let's give her some hair. There, she weighs 150 pounds. And then we got some babies. Those are the babies. And each one of these babies weighs 15 pounds. What's the average going to be closer to? Is the average going to be closer to the dad's weight or the baby's weight? The babies, because you've got more babies than you have of the dad. Okay? So now when we look at the weights or the averages on the periodic table, this average is 12.011. What atom, what's the mass of the atom that you have the most of? 12. Who said that? Good job. So most of the carbon atoms in the world have a mass of 12 because that average is closest to 12. If you look at oxygen, 15.99, what is the mass of most of the oxygens in the world? 16. Whatever that number is closest to is what you're going to have the most of. There is a math equation to calculate that. We're not there yet. We're going to get there. But this is on every single Regents, knowing how to calculate that average. Okay? So I wanted you to understand the difference between what that number is, and then if I just write down, hold on, let me climb back up here. Whoop. Okay. If I write down something that looks like this, you see how that's a whole number? We are talking about one atom. Okay, this is a mass number. Now, the mass number is equal to the protons and the neutrons. Because if you go back to this chart, there's only 2 things that have mass, the protons and the neutrons. So this mass number for this particular nitrogen is the number of protons and the number of neutrons in that atom. Somebody's there, right? I'm not losing my mind? I am losing my mind. Well, they have to knock loud. Like, you really have to knock. Maybe I can get like one of those little knockers that go. Okay? Alright, so nitrogen 14 means it has 14 as its mass. What is its atomic number? 7. It's a good number. Okay? This number right here is the number of protons. We talked about that before. Well, if it has 14 protons plus neutrons, not every time, okay, and 7 protons, how many neutrons does it have? 7. So it's going to have, protons we're going to make with a P with a little positive sign on it, 7. Neutrons is an N with a little 0, right, because it's neutral, so it's also going to have 7. How many electrons is it going to have? How many? 7. Yeah, because these two numbers need to add up to 0. I mean, they have to be 7 positives and 7 negatives. So they have to be the same number. It's not always going to be like that, but right now, that's where we are. Okay? So far, so good? Okay, so not always. Not always. So I'll do one that's not like that. So we'll say that this is the mass number, and this is the atomic number. And if I want to find the number of neutrons, I'm going to take the mass number and I'm going to subtract the atomic number. The mass number in this case was 14 and the atomic number was 7. So to find neutrons, it's the top number minus the bottom number. Now if this was a decimal, would that be a mass number? No, it's the average mass of all of the atoms in the world. And so what we can do is we could just say, all right, what's the one that we have the most of, and use that, which is what Trinity was doing before. She just said, all right, if it's 15.999, we'll just make it 16, and I'm going to get what it's closest to. You're going to round it. But most of the time it's going to give you in a whole number, which is going to be a mass number. So let's say I do like K37. First question, what is K? Potassium. So this is potassium. So we would call this potassium 37. Right? What is the atomic number of potassium? What number do we put down here? 19. That 19 is telling us that this sucker has 19 protons. How many neutrons does this have? 18 neutrons. Okay, 37 minus 19. How many electrons does it have? 19. Because the protons and the electrons are going to be equal to each other. Because the positives and the negatives cancel in a neutral atom. Right now, we are only doing neutral atoms. We have not talked about any atoms that have charges. Okay? All right, so you can see now that this 19 and 18 are not the same. What about if I did 40 and 19? The proton number is still 19. The neutron number is going to be 21. And the electrons are still going to be 19. What's the difference between these two? Number of neutrons. There is a big fancy word. Ready for your big fancy word? It is called an isotope. Anybody ever hear that word before? Okay. How would you define it if you had to write the definition? Same number of?
Same number of protons, different number of not neutrons.
Yeah, same number of protons, different number of neutrons. So let's write same number of protons, different number of neutrons. Okay? And keep in mind that protons, it's going to be your job all year now. Protons is atomic number. And if you change the number of... Yeah, we heard it, right? I'm going to make a big sign that says...
You get like a little doorbell.
I have one. I have one. No, I'm not... I bought it... Hold on a second. I have batteries. Hold on a second.
I'm gonna put it on the wall.
Finish this up. That way we can be done with this. Alright. Again, same number of protons. They could also say same atomic number, right? Because proton number and atomic number are the same thing. And different number of neutrons can also be different mass. Mass number. So be careful with that definition because they can use different words there. Same number of protons or same number of same atomic number, different number of neutrons, different mass number. These are called isotopes. Alright, that X that I just put up there, that X stands for any element. So let's do 27 and 14 and X 29 and 14. Are these isotopes of each other?
Yeah.
Okay, this is why they're isotopes of each other. Because they both have the same number of protons. That's a bad P. Okay, but they have different masses. What element is that? Silicon. Good. What about if they did something like this? Where you have two, let's say we do, let's do 20 and 41, and this one's 41 and 21. Are those isotopes of each other? No. So what element is this guy? Calcium. And this one's scandium. SC, I didn't ask you to remember that one, but calcium you should know. Okay? But they have the same mass. That doesn't make them the same element. You okay? Good? All right. Questions about any of this stuff? Easy peasy lemon squeezy? I have to hand something out, so I have to stop this. And here we go. Okay. Helium. What is the symbol, Ava, of helium? He. Okay. That's somebody, right? Okay. Atomic number is 2. The mass number is 4. Notice they called it a mass number and it's a whole number, right? Did Emma get one? Alright, how many, I'm not standing up here, so you write it in. How many protons does this thing have? 2. How did you know that? Same as the atomic number. So the atomic number and the number of protons are exactly the same. So let's write in 2 for number of protons. Alright, how many neutrons does this thing have? How do you find neutrons? Okay, the other way around. But mass number minus atomic number, or take the atomic number from the mass number. So 4 minus 2 is 2. And how many electrons does this thing have? 2. Because the number of electrons, the atomic number, the number of protons, and the number of electrons in an atom are all going to be the same. So as you go through this, double check yourself. The atomic number, number of protons, and number of electrons, these 3 columns should be the same. All right, let's do the next one. Magnesium. What is the symbol for magnesium? I'm hoping you don't need to look at your reference table. Ladana, do you know? Mg. Capital M, lowercase g. All right, we know it has an atomic number of 12. How do we find mass number? Mira, do you know? No? Okay, if I go back a page and I tell you that the number of protons and the number of neutrons equals your mass number, and I come back over here and I tell you the number of protons and the number of neutrons equals the mass number, what can I do? We can add these 2 boxes together to get the mass, correct? To get the mass. Well, we don't know what goes in this box. How do you know how many protons this thing has? Same as the electrons. Well, we don't have anything there. It's also the same as the atomic number. These 3 are the same. Atomic number, number of protons, number of electrons. All 3 of those are the same. So if this is 12, then this is 12, then this is 12. What is the mass of this magnesium? Loud, like you hate me. 24. I like it. 24. Because the mass number, and I'm going to highlight this. Okay, let's write it in. The mass number is going to be protons plus the neutrons. And then I'll highlight it in, I want pink. Where's pink? There's pink. Okay. That is protons and neutrons, is the mass number. Okay, number 3, even though it doesn't have a number. Caitlin? No. What letter does this? Ashley? Ashley? What is the symbol for zinc? Say it again?
Capital Z, lowercase I.
I like it. My old ears didn't hear it the first time. Okay, so that's zinc. We know that it has an atomic number of 30. That means the number of protons is also going to be 30. And the number of electrons is also going to be 30. Let's just finish this before we go anywhere. If this is the number of neutrons, how do we find number of neutrons, Olivia?
The mass number minus the atomic number.
I like it. So 65 minus 30 gives me how many?
35.
I like it. Okay, good. I'm stopping the timer. Go take your break. I'll open the door.